Hi everyone, welcome to this video. This is Durgesh from GCS Big Data Management team. So in this demo, today I'll be explaining about streaming mapping, leveraging the Kafka topic patterns and reading from multiple Kafka topics and writing into a multiple target HDFS files in a single mapping. So let's begin with that. So the basic use case that I'll be explaining today is related to the resource utilization when the streaming jobs are running. As one particular streaming mappings will be corresponding to the one Kafka topic being read. Hence, if there are requirement of reading from multiple Kafka topics, then corresponding separate mapping has to be created for each Kafka topic. And minimum resource allocation for a mapping that will be reading from Kafka topic will be around 3 vehicles. So if there is a requirement of reading from multiple Kafka topics, say hundreds or 200 Kafka topics at the same time for a streaming analysis, in that case, the resource resource utilization issue would occur, and the solution will not be optimal enough for scaling it up. So, how can we come out of this uh, problem and tackle this in a different way? So, in this presentation, if you can see the image, I have just explained a basic use case, real-time use case that many of the customers might have it, and how can that be achieved using Kafka topic patterns. So, the solution for this today's session would be creating a single mapping and reading from different Kafka topics and writing into a various HDFS file. And this can be achieved with uh, two parameters, that is called Kafka topic patterns, and another is file name port, which exists in the HDFS target file object that will be created in the mapping. So, for example, uh, in a real-time scenario, there are some 100 or 200 Oracle tables which is getting updated in a real-time basis, and that has to be consumed in the mapping and loaded into a for a reporting purpose or for an analysis purpose has to be loaded into a target. So in that case, the use case that I have taken over here is there is a Oracle tables which are getting real-time data, and it is being fed to the CDC publisher. CDC is nothing but a change data capture. It's another Informatica product leveraging the power exchange adapters, which gathers the uh, recent data that has been modified or changed in the source, and it creates a individual topic for the corresponding source tables, and these topics are then used in our BDS mapping and loaded into the HDFS file as in various formats. So how can we do this? Is the simplest way of achieving this is following a prerequisite for before creating a solution, is that the topic names that are fed to the mapping should have a common patterns in it, so that the mapping source will read from all the topics at the same time, which matches to the pattern that has been configured in the Kafka object in the mapping. So any topics having messages in uh, lying on those patterns will be read and process it and push it to the target. And in the target, since we'll be connecting each topic name to the file name port, in that case, the target files get created for corresponding to the each topic names. So in the further slides, I'll be showing you the demo. How can this be achieved in Informatica BDS from latest versions onwards. So prior to 10.2.2, the topic pattern Kafka header was not available, and this has been introduced to handle this kind of a scenarios. So the advantages of using this would be um, reducing the number of resource utilization on the shared cluster, and achieving the same use case that would be done from creating a multiple mappings. So let's just in the next slide, I'll show after once you start the BDS mapping, what kind of directories it gets created, what kind of files it creates, and the behavior of uh, the streaming mappings that will be creating a target files when you run the job. So as you can see, there are three screenshots here. So first is um, the there's a new directory gets created called active when you run the streaming mapping. So uh, prior to the active directory, that's a base directory that I have provided in my target object that I created in the mapping. And after that, it create a directory called active when the mapping is running. So just to depict that there is a real-time mapping that is running and it's an active state. And inside that, in the second screenshot, if you can see, it creates a parent directory with random numbers. And after that, post that, there will be two directories. You can see Optus demo and Optus interval. Those are the topic that is being read simultaneously from the single Kafka source in the mapping, and it creates a separate directory for them, and all the messages gets loaded into these directories which are coming from the source. So once the mapping gets killed or stopped, then you can see the base directory has two different directories get got created with the topic names, and which will have the content of the messages that is being transferred from the Kafka. However, whereas an active directory which was created in the beginning, it will have an empty content in it. Since the mapping has stopped, so it gets segregated and creates a separate directory in the base directory itself. So going forward, let me show you the demo out of it. So let me just create a new Kafka object using topic patterns. So this is Kafka object, and I'll be selecting the connection out of it. And let me just add some resource. So here you can see the list of topics that is available in my Kafka source. And so there are some common. So in this demo, I'll be using these two topics, which is having a common pattern of Optus underscore. So let me just use that pattern and create a Kafka object. So here the pattern that we will be providing, this name window, we will be using regular expression uh, compatible with the POSIX format. So that's why my common pattern is Optus underscore, and dot star is the characters further onwards that has to be considered. So I'll just say okay, go, and then I'll just select this, and then the Kafka source object has been created with the topic pattern as Optus dot star. So that means any topics falling into this name will be read in the mapping and will be created into the separate target file. So as you can see in this mapping, there is a topic name header in the Kafka object, which I have connected to the file name of a HDFS target file object. So that means individual topic name will be created in separate target file in the HDFS. So let me just start this mapping and send some messages to two different topics simultaneously, and we'll see the separate files got created after this. So I have started this mapping. Let me just go back to the server and publish some messages. So this is my Kafka server, and here I'll be publishing some messages. this topic I have sent some messages, and similarly I'll send for another topic called Optus demo. Topic demo 2. So I have sent these two messages. Now let's just see the application that is running under the. So yes, so my application has been launched and it is running here. Let's just monitor the directory in the HDFS. So this is my target object, and the file directory where it will be writing the files for separately for the individual topic will be this directory, and the prefix for the file name would be here I have given. So let's see the directory in the HDFS and compare the results. So yeah, this is the HDFS directory that I'll be looking, and here we can see that there is a directory called active got created here. So let's just go to the active and see the content of it. Yes, so there will be a random parent directory with the alphanumeric characters has been created. Let me just, and yes, so as you can see, there are two different directories got created for two different topics that was streaming from the Kafka sources, and we can just verify the content of these two. So these two directories has been created. Let's just stop the mapping and see the content of these two directories for the messages. So let's just monitor. So let me just cancel this mapping now. So now the mapping is cancelled. Let's just monitor the directory now. Yes. So as you can see, once the mapping was cancelled or stopped, under the base directory, there are two different directories got created, and these correspond to the topic name. If we just see the content of those, it should have the messages that has been sent in the source. Yes, so there is a file got created. Let me just display the messages in the. Yes, so this particular file has this message that was sent, and similarly, other directory also should have the same message that was sent in the source. Yes, for even for Optus interval, we got the message over here. So that means the same mapping was run, and it was reading from the multiple Kafka topics and created a different file directory under the HDFS. So as I said, the basic use case for this application would be to avoid using multiple resources and in the shared cluster and avoiding creating repetitive mappings for reading from various Kafka topics if it is the common logic of reading from the Kafka is similar. So that repetitive work has to be avoided, and also it will be benefit for optimizing the resource utilization for such use cases. So as you can see, a single BDS mapping was using three containers and the five ecos in the under the Spark application type. So yeah, that's it for the demo. Thank you for watching this video. Looking forward for your feedback. Thank you so much.